Imagine you're boarding the fastest spaceship ever built by human hands, right now, and you start a journey across our galaxy. By the time you reach the other side, the human race wouldn't just be gone, it would be forgotten. Because you're not just traveling across space, you're racing against time itself. This is the Milky Way. And once you truly grasp its scale, everything changes. You realize that crossing the galaxy isn't just about how fast you can go, but whether humanity could even survive long enough to arrive. We live here on a small blue planet orbiting an average star about 25,000 light-years from the galactic center, roughly halfway between the crowded core and the quiet outer edge. It sounds like a precise location, but in reality, it's more like saying you're somewhere in the middle of an ocean, because that's what the Milky Way really is, an ocean. And we are not just small within it, we are almost non-existent. Now here's where things start to get strange. On a clear night, far away from city lights, you can look up and actually see part of our galaxy. A faint, glowing band stretching across the sky. It feels massive, overwhelming even. But what you're seeing in that moment is a lie of perspective. Because with your naked eye, you can only see about 2,500 to 3,000 stars. Out of hundreds of billions, that means you are seeing less than 0.00001% of the Milky Way. Think about that. Everything you've ever seen in the night sky, every star you've ever pointed at, every constellation you recognize, is just a tiny fraction of what's actually there. Most stars are too far away, too dim, especially red dwarfs, small, faint stars that make up the majority of the galaxy, invisible to you without a telescope. So the question naturally follows, if what we see is almost nothing, then how big is the thing we can't see? The Milky Way is estimated to contain between 100 and 400 billion stars, possibly more. And around those stars, planets, maybe hundreds of billions, possibly even trillions. Already that number is difficult to comprehend. But the real shock isn't how many stars there are, it's how far apart they are. The Milky Way stretches across roughly 100,000 to 200,000 light-years. And a light-year isn't just a unit, it's a limit. It's the distance light travels in 1 year, about 9.5 trillion kilometers. So when we say the galaxy is up to 200,000 light-years wide, we're saying that even light itself, the fastest thing in the universe, needs 200,000 years to cross it. Now pause for a second, because this is where the scale breaks your intuition. Imagine shrinking the Milky Way down to the size of Europe. At that scale, our entire solar system, the Sun, Earth, every planet, every asteroid, would be about the size of a single bacterium. Not a grain of sand, not a pebble, a bacterium. Something you wouldn't see. Something that effectively doesn't exist at that scale. And that bacterium is everything you've ever known. Now here's the twist. The Milky Way itself? It's just one galaxy, out of an estimated 2 trillion in the observable universe. 2 trillion galaxies, each with hundreds of billions of stars, each potentially filled with planets, systems, maybe even life. So the Milky Way isn't the universe. It's not even close. It's a single point in something so vast, it barely has meaning on its own. And that realization sets up the real question. Not how big space is, but what it would actually take to cross even this one galaxy. Let's start with what we have, right now. The fastest object humanity has ever built is the Parker Solar Probe. It reaches speeds of about 700,000 kilometers per hour. That's fast enough to circle Earth in minutes. Fast enough to travel from New York to Berlin in less time than it takes to watch a short video. At human scale, it's almost unimaginable. But at galactic scale, it's nothing. To understand why, let's take that speed and apply it directly. Imagine putting the Parker Solar Probe on a straight path across the Milky Way. No stops, no slowdowns, just constant speed. How long would it take? About 300 million years. Let that sink in. 300 million years. That's longer than humans have existed as a species. Longer than most complex life has existed on Earth. You wouldn't just die on that journey. Every trace of your civilization would vanish before you made even a fraction of the trip. So naturally, the next thought is this. What if we just go faster, much faster, close to the speed of light? Now we enter a different world entirely. Because at those speeds, something unexpected happens. Space and time stop behaving the way you're used to. According to Einstein's theory of special relativity, as you move faster and faster, time for you begins to slow down relative to everything else. At the same time, distances in front of you begin to shrink. Not physically in some absolute sense, but from your perspective as the traveler. This is where things get almost surreal. Imagine you're on a spaceship traveling at 99.9999% the speed of light. From Earth's perspective, you're still crossing a galaxy that's 200,000 light years wide. So the journey still takes roughly 200,000 years. But for you, it feels completely different, because time on your ship is slowed down by a factor of about 700. That means while 700 years pass on Earth, you experience just one. Now apply that to the full journey. Those 200,000 years. For you, they shrink to around 285 years. A journey that would outlast civilizations becomes something that could, in theory, be experienced within a few human lifetimes. And it doesn't stop there, because from your perspective, the galaxy itself isn't even 200,000 light years wide anymore. Due to length contraction, the distance compresses. The faster you go, the shorter the distance becomes in the direction you're traveling. So for you, inside that ship, the Milky Way might only appear to be a few hundred light years across. Not because it actually shrinks, but because space itself adjusts relative to your motion. This is the part that feels almost impossible to accept. You're not just moving through space, you're changing your relationship to it. But there's a problem, a serious one. To reach the speed of light, you would need infinite energy. Not a lot of energy, not future technology levels of energy. Infinite, which means it's not just difficult, it's fundamentally impossible. You can get close, closer and closer, but you can never actually reach it. And even getting close comes with consequences. At those speeds, even a tiny speck of dust becomes deadly. A grain no bigger than a particle could hit your ship with the energy of an explosion. Radiation in front of you would shift into dangerous high-energy wavelengths. The entire universe ahead would compress into a blinding, lethal beam. Your ship wouldn't just need to be fast. It would need to survive a universe that becomes more hostile the faster you move through it. And even if you solved all of that, there's one final problem: communication. If you left Earth today on a journey like this, traveling near the speed of light, from your perspective, you might reach the other side of the galaxy in a few centuries. But from Earth's perspective, 200,000 years would pass. Everything you knew would be gone. Everyone, every language, every city, every memory of you, erased by time, and any message you tried to send back would take tens of thousands of years to arrive. You wouldn't just be traveling through space, you'd be traveling away from your entire timeline. So here's the real tension at the heart of all this. Not, can we cross the galaxy? But what would it even mean if we did? because technically, under the laws of physics, it's not entirely impossible to imagine a journey like this. But practically, emotionally, humanly, it changes everything. You wouldn't return home. You wouldn't even share the same reality as the place you left. You would become something else entirely. A traveler not just across distance, but across time itself. And maybe that's the most unsettling part. Not how big the galaxy is, not how long it takes to cross it, but the realization that the moment you try, you lose the world you came from. And yet, there's something strangely fascinating about that, because even if we never make that journey, even if it remains forever out of reach, the fact that we can understand it, that we can imagine it, that we can calculate it down to centuries and years, says something profound about us. We are creatures standing on a microscopic world inside a galaxy that barely matters in the grand scale of the universe. And yet, we can grasp its size. We can ask these questions. We can look into the night sky and not just see stars, but wonder how long it would take to cross them. And maybe that's the real story here. Not the distance, not the speed, but the fact that we are aware of it at all. I really hope you enjoyed this video. If you're curious about the limits of human space travel, consider subscribing. I'll see you in the next one.